going to take a look at triangle congruence. Now, there's a reason why things are the way they are. You need to make sure that you identify the rules before you can go and state anything. Okay? Now, what we've got here, corresponding sides and corresponding angles of polygons are those that are the same position at two different polygons. Okay? Same thing. So, if I want to identify corresponding parts, the easy bit is it's already done for us. So if I got triangle XYZ, I got triangle KLM. Based upon what we see here, the X goes to the K. The Y goes to the L. And X goes to M. Well, if we're just talking about corresponding parts, that's all that we need to deal with. Okay. This goes to that, that's all it is. So the order does matter. Now, what you're getting at was more or less, are they congruent? Are they the same? Is there equality going on? That comes under this idea. Now, it says, triangles are said to be congruent when all of their corresponding sides and corresponding angles are congruent. One way to determine if two triangles are congruent is side, side, side. So the postulate that they have here, make sure that you get that into your little book. All right. So, what I want you to do, sheet of paper, grab a blank sheet of paper. And what I want you to do is I want you to make a triangle that is this size. I want one that is going to be 4 inches. I want one side that is going to be 8 inches. And I want another one that is going to be 7 inches. I want you to make a triangle that has those exact dimensions. What? I don't know. I don't know. It's a triangle that has these measurements on it. Okay? Well, give you something to think about. All right, so you've had a little time to work on that. I suppose I can make my own here. Let's see. I need one that's 4. There's one that's 4. Then I need one that's 7, right? I go up to 7. And then I need one that's 8, correct? So, I got to turn these into some kind of triangle, right? Let's see here. I just realized something. I can't use these. I can't use lines because I need it to do something that won't work. Now, the properties do not work. Okay. All right. So there was my 4. My 7. Yes, I need to use rectangles in order to do this because the rectangles allow me to do a rotation. Okay, so I got 8. So I set this over here as my base. Got this one here. I'm going to have to rotate it in some shape or form, right? Do that. Got this one here. Put that here. Now, let's see. You said right triangle doesn't work, right? You say? Let's see, well, that's a little short right there, isn't it? Okay, well, could I take this? Can I go and rotate this a little bit like that? And, whoops, that is not what I wanted it to do. Don't know why it did that. There it goes. So, why are you doing that to me? So I got to do a little more of an angle there. That's almost too much. That's better. Ooh, pretty close, right? Well, yeah, it should connect. I mean, that means that I'd have to do a little. Well, no, I understand what you're saying here. I do have some limitations on what I can do here with this. But my question now goes to you guys is if I've got a triangle that looks like this, that one is 4, one is 8, one is 7, are all of the triangles made like this exactly the same? Is every one of them going to have the same angle? So why don't you go and, now that you've got this drawn out, or at least attempted to, does your triangle fit the same, look the same way mine does? Okay. Look at your partners. Somebody next to you there, look at theirs. Does their triangle look like yours? Okay. So they're kind of close, maybe not exact. But I got a question for you. If I wanted to make a whole lot of triangles and they were going to be 4 inches by 7 inches by 8 inches, is there any other way that I can go and make this triangle? Is there another way I can rearrange these sides such that I'll have a triangle like this? I can't change the measurements. Well, I could rotate it, but it would be the same triangle. If I said that I wanted to have this one over here, and I wanted this one over here, oh, I want to make that a triangle, right? Let's see. So I'm going to, whoops, what I wanted to do, I'm going to flip to the, disappeared, where'd it go? Wasn't supposed to do that. Well, if I wanted to do that, I got to do this again, right? Change my rotation around, spin them around, move them around. Okay, so I got it close again. So my question now is, that's pretty much the same triangle as the other one? It just rotated around, right? Flipped over, however you want to look at it. So are all triangles that are 7 by 8 by 4 going to be exactly the same? Absolutely correct. There is no other way that you can go and create a triangle that'll do this. No other way that you can arrange the sides. So all triangles that are like this are congruent. That is why we can get by saying that if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So, if I look at this, we have what is called, they say, triangle rigidity. It is only going to be a triangle that looks like this. All of the angles are the same, all of the sides are the same. And the corresponding ones, if we take a look at this, angle A corresponds to D. So angle A, angle D. B goes to E, so I got 2 up here, 2 there. C, here, F, there. AB, A to B, is the same as D to F. Those sides are congruent. B to C should be the same as E to F. B to C, E to F. Now, the last ones could be A to C, D to F. Now, mind you, you can go and turn the order, E, F, and F, E are the same thing, correct? Same sign. Generally, we want to go in alphabetic order, just to keep that in mind. So, if I want to name the congruent triangles here, so if I start off with the first triangle, and that's KLM, right? The next triangle, which angle corresponds to K? That's got to be P, right? What corresponds to L? Well, that would be Q, correct? Which one corresponds to M? Well, that would be R. So I end up with PQR. And that's how we have to identify it. Now, mind you, you got to put the triangle symbol out in front of it, otherwise it's meaningless to us. Okay? Now, next, and I'll give you a few moments to put that in here, but in the box again, you need the CPCTC. Corresponding parts of congruent triangles are congruent. Okay, so this is going to be, remember when we were talking about the proofs and the rules that we can use for proofs? This is one of the rules that we get to use. If we have identified that certain things are congruent, this is going to come into play for us. So that, and along with SSS, we've got that for identifying whether things are congruent. So if I wanted to write a congruent statement, there are 6 things that are identified as congruent here. Angle A is going to be congruent to angle what? X. Angle B is going to be congruent to angle Y. Angle C is going to be congruent to Z, because we see that we've got the marks there. Now, the other part of this thing is going to be segment AB is going to be congruent to what? Which is the corresponding one? XY. Now, if A goes to X, X has to go first. We cannot go AB and then say YX, because then we're saying that those points go to different places. So if I do AC is going to be congruent to what? XZ. And if I say that BC is going to be congruent to, it is going to be congruent to what? YZ. Again, we need to make sure that when we write these out, we use the proper identification. So, I'm going to give you a moment here, and I want you to identify all corresponding parts. What would be the next one? Q and U, just Q and U. What do I got to put in front of them so that I know what I'm talking about here? Yeah, I know, but you didn't say angle, so I can't assume that that's what you meant. Angle Q goes to what? We have to make sure we take the time to put things down properly. So, Mr. Rabikowski, what's something else? We took care of the angles, now we got sides left, so which side is which? Okay, so we got RQ, but how do I go and identify that? What would I say? What's the word that we use to identify what that is? Put the line, okay, we got to put the line across, so that means it's a segment. So RQ goes with, you said segment what? UT. Got to make sure the order gets. So, let's see. Logan, what do we got for the next one? So I got just PR. Well, you'd want to say segment. Okay, so segment PR goes to which one? ST. That works. So what else we've got here? Let's try Jacob. What do we got? What's left? P what? PQ. We need segment PQ. Okay. So we get segment PQ, and it goes with what? SU. You can't just identify it by letters. You have to make sure that you are properly identifying everything there is. So, I'm going to give you a few moments and I want you to write the congruent statement of what you see. Okay, Caleb, what do you think we should write down for the congruent statement here? Well, we want to put congruence in there, so it's that one, but then it's going to be triangle which one? Is that correct? There you go. That was it. That's all it was. So, give me a moment. I want you to think about this. All right, so Hayden, we're supposed to identify congruent sides and angles of the two triangles. So, what would be the congruent statements for this one? Correct. Because I need this here for the sides and for the angles. So, what would be the sides? If I wanted to identify which sides are congruent, which ones would they be? Okay, well, values are equal, objects are congruent. So that would be, you said JL would go to SU. Good. What's another one? Okay, is congruent to, you say which one? UT. And what's the last one? Oops. So you want KJ is congruent to, you got to say the congruent to, UT. Incorrect. ST. Incorrect. TS. Because K goes to T, J goes to S. So we have to make sure that things are in their proper order. So, Mason, what about the angles? What do we got there? Okay, so that's congruent too. It isn't enough to label them. We've got to say the words congruent to that. So what was the next one? And the last one would be so he switched the order there. Is that legal? Sure. I mean, you were just identifying that this is congruent to that. That does identify all the bits and pieces. So, we're going to end it there, and I'm going to let you get to work. That's the assignment due at the end of class tomorrow.